Hi, this is Farooq Hashmi from thinkingneuron.com. In this video, I'm going to talk about a data science interview question which I ask to almost every candidate. How did you measure the accuracy for your regression model? So, this question can reveal whether you have really worked practically on a regression model and really had to explain the results to a client or not, or have you just learned it from some online source and memorized the concepts. Okay, so let's get started. So first of all, let me point out about regression models. So whenever we say regression models, so we are talking about the supervised machine learning techniques, and these models are employed, regression models are employed when you have to predict a continuous number. So when I say continuous number, please imagine sales, demand, number of passengers, etc. So any value which can vary between two set of minimum and maximum, and it can take any continuous number within that range. Okay, so that is what we call a continuous number, and whenever your model is predicting something like that, then we say you are doing regression. Okay, now in these scenarios, how do you measure and tell your client that this is the accuracy of my model? This is what I'm going to discuss in this video. All right, first of all, let me start with a common misconception that r squared is taken as the accuracy measure, but it is not the accuracy. Accuracy is measured using 100 minus MAPE or 100 minus median APE, the calculation which I'm showing here in the table form. Okay, I'll discuss that quickly now. But make sure that you do not mistake your answer as r squared. The moment you say, I measure the accuracy of my predictive models using r squared, you are clearly showing off that you have not explained it to the client, because r squared is something which we use as goodness of fit measure, and this is like fit of your training data uh, in your model. Okay, and this is not representing the actual accuracy which you test on the testing data or the validation data which you keep aside to see whether the model has really understood the patterns or not. Okay, so since you are doing a continuous number prediction, like in this scenario, you can see there is a original column and there is a prediction column. So the original column was already present and the prediction column is something which you have generated based on your machine learning. Okay, this is generated by machine learning. But where is this being generated? So first let us talk about these from where this original and prediction is coming. So whenever you do machine learning, you have total full data with you, all the historical data, but you don't use the whole data in your machine learning training. So what do? You split it. You split it into train portion and test portion. A significant amount of data is training. So let's say a common split is 70% training and 30% testing. You can do 80% and 20% also. It's all about sampling theory. So you randomly sample the data. Some of the rows you keep in training, some of the rows you keep in testing. And why do we do this? We do this to check whether our model is able to understand the data patterns in the training data or not. Okay, we test it using the testing data. So if I just mark down one more column over here and call it my target variable, which is like what you're predicting. So your sales or demand or number of passengers, the target variable which you're trying to predict, it is present over here also and over here also. Okay, because this full data itself has been splitted into training and testing. So using the training data, I learn the patterns, I create my machine learning model, and then once I know this, that these are the patterns, I have understood this, so I'll pass out my test data to it. So this target portion, let me rub this target portion and bring it over here. This is nothing but my original. I know the answers, I know these values, so I have sent these testing target values over here, and using machine learning, so I pass this data to machine learning algorithm, and this produces some result. And what is that result? This is nothing but prediction. Yeah. So this original is something which I know that this must be the answer, and prediction is something which I have generated using my machine learning model. Okay. And then I'm going to compare that this was the original, this is the prediction, how far away these values are. Okay. Now during the hyperparameter tuning of algorithms while we are training, common values are utilized such as RMSE or MSE, MAE, etc. But these values are highly affected by the scale of the data. So if if you try to explain the accuracy to the client, in the end what your client is going to see is this table, that let's say original value was 20 and what your model has predicted 25. So how far away this 20 is from 25? You will say, let me compute the percentage difference. So how do we compute the percentage difference? 20 minus 25 divided by 20, this whole thing multiplied by 100, take the absolute of it. So this is nothing but the absolute percentage error which we calculate. So I say 25 is 25% far away from 20. 30 is 3.2% far away from 31. 29, the prediction is 12.1% far away from the actual value 33. So how far away the prediction is from the actual value or the original value, this is what I'm measuring in absolute percentage error. In another words, you can say that in every prediction, this is the amount of error I am making. Like here in the first row, I'm making 25%, 3.2%, 12.1% error, 5.3% error, so on and so forth. So if I have to tell my client that how accurate my model is, what I'll do is I'll try to calculate on an average how much error I am making. So this is that value, the MAPE is that value, which is nothing but the mean of this whole column. So 100 minus this MAPE, this becomes my accuracy. And this is what I have described here, that 100 minus MAPE will give you that this is on an average how much your model is accurate, because you are subtracting the error portion from the 100 value. Sometimes this MAPE would be really huge due to the presence of some outliers, and the absolute percentage error would be really huge. So what we look at, the another measure of central tendency, which is median value. So we do 100 minus median APE. Right. So both these measures are looked into while describing the accuracy to the client. Right. And in an ideal world where your errors are not having any outliers, your data is good, mean absolute percentage error and median absolute percentage error, they'll come really close, and the accuracy for both these terms will be similar. Right. So this is one way, and this is majority of the places which clients, which in majority of the cases clients would understand this terminology and they'll be able to appreciate it. If you give them the RMSE value, MSE value, or let's say the R squared value, you are not giving them the exact way to measure how accurately the model is performing. Okay. So in order to make it simpler for the client, we use this metric, which is MAPE. All right. Because this is a scale less metric, it works for every scenario, and it is just measuring that this was the original number and how far away your prediction is from the original number. All right. Now in some cases I have also seen the clients utilizing their existing data using bias. So what is bias? So they try to measure the accuracy using bias. For example, here if you take a look into the 4 rows of prediction which I have tabulated, and if you sum this up like 20, 31, 33, 38, so you can get an overall summation of this column. Similarly, you can get an overall summation of this prediction column. So for example, 20 plus 31 plus 33 plus 38, how much that evaluates. So I've done that already. So it evaluates to 122. And if you add up the predictions like 25, 30, 29 and 40, how much it adds up to? So it adds up to 124. So now this overall sum is measured as a deviation or as a bias. Okay, so now I will collectively try to measure that if I sum up all the prediction versus the sum of all the original, how far away these two numbers are. This is nothing but my bias. Okay, so how then I will calculate the bias? Bias will be once again calculated as 122 minus 124. This is the sum of original, and this is the sum of prediction, and then divided by original reference, sum of original, which is 122. Okay, so this will produce me, let's say this is going to give me 1.63 minus 1.63. So this is nothing but the difference, and I take the absolute value, so 1.63. So 100 minus 1.63, this becomes my accuracy. So I'll say my model is 98.36 accurate. So all in all, like if you take the summation of all the original and summation of all the prediction, how far away they are from each other. So they are 1.63% far away from each other. So if they are far away 1.63%, so how accurate my model is? 98.36%. So this is also known as bias, and it is also utilized in some of the scenarios, although it has its own demerit, because in some cases it will simply add up the problems, and overall impression would be of a highly accurate model. If you see in this scenario itself, the accuracy based on 100 minus MAPE would be somewhere around 88%, and based on bias it is coming as 98%. So a 10% jump you are witnessing when you are employing bias. So bias is something which prints a very rosy picture. So that is why bias, if you are using, you must always use it in conjunction to the NAPE, because this will give me event level accuracy or the row level accuracy, and this will give me overall accuracy. Okay, which is sometimes misleading, because wherever you have made errors in predictions will get added up to where you have not made it, or made the errors in the negative direction, and then all of them would add up to a near value, and it will not give you a very correct sense of the model's accuracy. All right, so what is the final number which I always prefer? It is 100 minus MAPE whenever I am measuring the regression models. Okay, and sometimes if the client demands, we can also include bias as well in the dashboards. So I hope this helps you clarify how do you measure the accuracy of regression models when you are deploying them for the client and when you are trying to explain it to the client, right? So 100 minus MAPE is something what we use in conjunction with the bias value. All right, all the best for that interview, and I hope you crack it.